Good morning everyone. So in the last lecture we have revised some integration parts, right? So continuation that, let us revise next topic, that is integration by parts. Now integration by parts, when you will use, whenever two functions are multiplied, right? For example, let's say u and v are functions of x, then how you will find the integral of u into v, right? So what is the formula? First function, that is u, into integral of second minus integral of derivative of first into integral of second, correct? So this is the formula to find if two functions are multiplied. Now important is which function is to be considered as u and which function is considered as v. Okay, u and v कशाला assume करायचे. For that we are going to use one rule, that is LIATE. Okay, L means what? It's a logarithmic function, correct? Then what is I? I is, yes, inverse trigonometric function. Then what is A? A is algebraic function. Then what is T? T trigonometric function. And what is E? E for exponential function. Okay, so this is how you are going to consider u and v, right, from the left hand side. So from the left hand side, whichever function comes first, that will be your u and next function will be v. For example, integral x into tan inverse x. Now here are two functions, one is algebraic, that is x, correct? Let us write this. One function is x, that is what? Algebraic function. Then tan inverse x, it's a inverse trigonometric function. So which function is to be considered as u, which function is considered as v? For that we are going to use this rule. According to this rule, from left hand side, starting from left hand side, which function comes first? I. First comes inverse trigonometric function, then algebraic function. So in this case, this will be your u and this will be your v, and then you can use this formula. Okay, right. So let us see some important examples from this topic. First example is integral I is equal to integral cos inverse root x into dx. Integral cos inverse root x into dx, correct? Okay. Now for this there is only one function. What is that function? It's a cos inverse root x, it's a function, it's an inverse trigonometric function, correct? Now to find integral of this, we need to create two functions. Okay, how you will create two functions? By putting root x as t, by assuming root x is equal to t. So if root x is equal to t, differentiating with respect to x, root x derivative 1 upon 2 root x dx will be equal to what? Dt. So what about dx? Dx will be 2 root x dt, correct? I have taken this 2 root x to the RHS. So what about dx? Dx will be equal to 2 into, what is root x? Root x is t into what? Dt. So your original integral becomes, see what is original integral? Original integral is cos inverse root x into dx. This becomes integral cos inverse, what is root x? Root x is t, correct, into what is dx? Dx is 2 dt, 2t dt, right? Now how you will find integral of this? See here, so we need to solve what? I is equal to, I am taking this 2 outside, and in the bracket it is cos inverse t into t into dt. Correct? This we need. So now we have two functions. What are these functions? Cos inverse t. What is cos inverse t? Cos inverse t, it's a inverse trigonometric function. What about t? It's a algebraic function. So according to our rule, LIAT, what comes first? Inverse trigonometric function. So this will be your u, correct? And this will be your v. So I will be equal to, let us apply the rule, 2 in bracket, first function, what is first function? Cos inverse t into integral of second minus integral of derivative of first into integral of second, right? So this is equal to 2 in bracket cos inverse t into, what is integral of t? T square upon 2 minus integral, what is derivative of cos inverse t? Yes, what is derivative of cos inverse t? Derivative of cos inverse t is minus 1 upon under root 1 minus t square into integral of t. What is integral of t? T square upon 2 into dt. Is all the terms clear? See here, cos inverse t we have taken as it is, then integral t dt, t square by 2, then derivative of cos inverse t minus 1 upon under root 1 minus t square, and integral of t, it is what? T square by 2. Now let us find this integral. So 2 in bracket, this is t square into cos inverse t upon 2, correct? Now minus minus, it will become what? Plus, and what term you are having? Minus minus, it will become plus, or what you can do, you can keep this minus sign as it is. Okay, keep the minus sign as it is. Why? See here, I am keeping minus sign as it is, and this becomes minus t square upon under root 1 minus t square dt by 2. Is this clear? See here, minus I have kept as it is, minus t square upon under root 1 minus t square into dt by 2, right? So you can cancel these two. See, this 2, it will get cancelled with this when you are multiplying with 2. So what you are having now? The terms remaining are integral t square into cos inverse t minus. Now to find integral of this, we need to adjust the term. How you will adjust the terms here? This is what we need to find out. So what I am doing? I am adding 1 and I am subtracting 1, correct? And let us split the integral here. Okay. So from this you will have two integral. First one is, so first term as it is, minus, what is first integral? 1 minus t square upon under root 1 minus t square dt, minus minus, it will become plus, integral 1 upon under root 1 minus t square into dt, correct? Okay. So further it becomes okay, this is equal to t square into cos inverse t minus, this will result into what? Correct? Integral under root 1 minus t square. What is integral of this? Integral 1 upon under root 1 minus t square dt. What will be integral of this? Yes, see, in the last lecture we have talked about this integral 1 upon under root a square minus x square. Is it correct? Right? So integral of, yes, sine inverse, correct, sine inverse of t plus c. correct? Okay. Now important is how you will find integral of this, right? This term. Now in the same part we have the three formulas. What are the formulas? Important formulas we need to remember. First one is integral under root a square minus x square dx. Okay, let us revise here only. So what is that? It is x by 2, correct? X by 2 under root a square minus x square plus a square by 2 into sine inverse of x by a plus c, correct? Which we are going to use here. Then what is the second formula? Integral x square plus a square dx. Formula is what? X by 2 under root x square plus a square plus a square by 2 into log of x plus under root x square plus a square dx plus c, correct? And what is the last formula? Last formula is integral under root x square minus a square dx. So what is the formula? It is x by 2 under root, same term, x square minus a square by 2 log of x plus under root x square minus a square plus c, right? So out of these three, which formula we are going to use? We are going to use first formula, correct? This one, under root a square minus x square. So what is value of integral? Integral first term as it is t square into cos inverse t minus x by 2. So it will be t by 2 under root 1 minus t square plus a square by 2 sine inverse of t, correct? Plus sine inverse of t plus c. So this is your final answer. Okay, is the example clear? So it is one of the important example we need to remember. Okay, what is integral of cos inverse root x, right? What is the substitution we made? Substitution was root x is equal to t, and then you get dx as 2t dt, and then we have used, see, because why this example is important? Because substitution is there, we need to use integration by parts, also we need to use some special integral. Okay, right. See the next example now. Integral sec cube x dx, write down integral sec cube x dx. This is also one of the important, integral sec cube x dx. Example number 2, integral sec cube x dx. Alright, you can try integral sec, you can pause the video, you can try integral sec cube x dx. Okay, see here how you will get the integral of this. Okay, so what we need to find out? See, we know integral of sec square x, so I am splitting this as sec x into sec square x dx. Okay, now sec cube x I have split into two functions, both are trigonometry. So how you will decide which function is considered as u, which function is considered as v? For that, simple thing is, which integral we know? See, integral even sec x is known to you, okay, no doubt. But if I am considering this as u and this as v, what will happen? See here, let us say some students consider this as u, this as v. Okay, don't write, just see what will happen. So first function, what is first function? Sec square x into integral of second. What is integral of sec x? Log of sec x plus tan x. Okay, terms are increasing. minus integral. What is derivative of sec square x? It is 2 sec x into derivative of sec x is what? Sec x into tan x. Okay, so unnecessary it is increasing, terms are getting increased. Instead of that, what we will do, we will assume this as u and this as v. Okay, then see what happens, whether term get reduced or not. First function into integral of second, correct, minus integral derivative of first into integral of second. The terms are not increasing, remember. Okay, so sec x into what is integral sec square x? It is tan x minus integral what is derivative of sec x? Sec x into tan x, correct, into what is integral of sec square x? It is tan x into dx. Okay, see here, sec x I have carry as it is. What is integral sec square x? It is tan x. What is derivative of sec x? It is sec x tan x. What is integral of sec square x? And this dx as it is. Okay, hope all the terms are clear, correct. So now this becomes sec x into tan x minus integral sec x as it is. This will be tan square x, correct, tan x into tan x, it is tan square x dx, right. So this is equal to sec x into tan x minus integral sec x into tan square x. Instead of tan square x, can we replace tan square x with sec square x minus 1? Is this correct? Because 1 plus, we know 1 plus tan square x is what? Sec square x, correct? Okay. Now let us multiply this. So when you are multiplying this, you will have sec x into tan x minus sec x into sec square x, it becomes sec cube x dx, minus it will become plus into sec x into dx, correct? Okay. So what integral becomes? I is equal to sec x into tan x minus what is this? Integral sec cube x dx. What is integral sec cube x dx? It is nothing but I, correct, plus now what is integral sec x? Integral sec x is log of sec x plus tan x plus c. I am taking to the left hand side, I plus I, it will become 2i. You can shift here. So I will be correct. So this is how you will find integral of sec cube x. This is also one of the important. Okay. So hope this part is clear. Which function is considered as u? Which function is considered as v, and why? Okay. Right. So let us see next one. Hope this example is clear. Next is integral Okay, integral sec square x into under root tan square x plus tan x minus 7 into dx. Okay, integral sec square x into under root tan square x plus tan x minus 7, right? Okay, so what topic we are learning? We are learning integration by parts, correct? Okay, so we need to convert this example in that form, u into v form. So first we will use method of substitution. So you observe here, if I put tan x is equal to d, sec square x dx, it will become dt, right? If I am putting tan x as t, sec square x dx, it will become what? Dt. So my integral becomes, see here, sec square x dx, sec square x dx, it is dt, and in under root, what term I am having? I am having tan x as t, so it will become t square plus t minus 7. T square plus t minus 7. Is this correct? Okay, t square plus t minus 7. Now how you will find integral? For this, in the beginning of lecture, right, in this start, we have discussed these three formulae. So out of these three, we need to use one, right? See here, in both the terms, we are having perfect square, x square plus a square, here also x square, a square, here also a square, x square. So we need to make perfect square of two terms. For that, what is our methodology? 1 by 2 into coefficient of t. What is coefficient of t here? 1 bracket square. So we are going to add and subtract 1 by 4. We are going to add and subtract 1 by 4. Correct? So I will be equal to integral under root t square plus t plus 1 by 4 minus 7 minus 1 by 4. Is this correct? Okay, into what? Dt. Into what? Dt. So this becomes integral under root t square plus t plus 1 by 4. Now how much is this? Minus 7 minus 1. So minus 28 minus 1, it will be minus 29 by 4. Minus 29 by 4 dt. Correct? So now we are going to write this first three term as perfect square, this term as perfect square, right? Because we need both the terms as perfect square. So it will become, see here, I will be equal to integral under root. This is perfect square of what? See, first term it's a square of t, correct? 1 by 4, it's a square of 1 by 2. In the middle you are having plus sign, so give here plus sign, bracket square, minus 29 by 4, right? We need to write 29 by 4 as a perfect square. So what you will write? We need to write under root 29 by 2 bracket square into what? Dt. So this becomes which form? Under root x square plus a square, correct? So what is the formula? X by 2, correct? X by 2. Please see carefully. X by 2 under root this term as it is. So it is t plus 1 by 2 bracket square minus root 29 by 2 bracket square, correct? X square minus a square. So we need to give here minus sign, minus a square. A square is this, a square by 2, right? This is your a square. This is your a square. So it will be root 29 by 2 bracket square by 2 into log of x. What is x? X plus under root x square minus a square. right? So if you are still confused, this is of the form under root x square minus a square dx, and we have written this as x by 2 under root x square minus a square by 2 log of x plus under root x square minus a square plus c. Okay, let us compare this. This is your x by 2, this is the square root term, this is a square by 2, this is your log term. Right? And in the end, what is t? T is tan x. So wherever you are getting t, you have to replace it with tan x. Correct? Okay. Next, right? So hope you are getting this example. Next one, integral log of log x upon x dx. Integral log of log x into divided by x. Right? This is also one of the important example. Integral log of log x upon x dx. Right? So for this, what will be substitution? Let log x is equal to t. So differentiating with respect to x, 1 by x dx will be equal to what? Dt. 1 by x dx. So this becomes dx by x will be dt. So integral becomes what? Log of log x. What is log x? T. And dx by x is what? Dt. This becomes your integral now. Integral log t dt. Now we know how to find integral of this. Integral of log x. What we do? Log t into 1 into dt. So what are these function? Log t, it's a logarithmic function. 1, it's a algebraic function, right? X to the power 0. So LIATE, what comes first? Correct? Log come first and then A. So log t is your L, 1 is what? Your A. So let us use this now. Let us apply the formula integration by parts. So first function into integral of second minus integral derivative of first into integral of second. So this becomes log t into what is integral 1 t, correct, minus integral derivative of log t into integral of 1 into dt. So if you are still confused, here log t I have written as it is, integral 1 I have written t, derivative of log t it is 1 by t, integral of 1 it is t, and this dt as it is, right? So write the next step now. Write the next step. So it will be log t into t minus this t, you can cancel. So integral dt, what is integral dt? And what is t? T is what? Log x. This is your answer, correct? Okay. correct. Next one, see. Okay. Next, let us see one important example. Integral x to the power 7 upon x plus 1 dx. Integral x to the power 7 upon x plus 1 dx. Right? Now, here numerator is what? Greater than denominator. Okay. What is numerator? Power. Power of numerator. What is power of numerator here? 7. It is what? Greater than power of denominator. So, whenever you will get such type of cases, what we need to do? We need to carry out division. So, we are going to divide x to the power 7 with x plus 1, right? X to this is what? X to the power 7 divided by x plus 1. Let us carry this division. Okay? Okay. How we will divide? X to the power 7, take the first term, x to the power 7 divided by x, it is x to the power 6, multiply these two. So, x to the power 6 into x to the power 7 plus x to the power 6, is this correct? We need to carry out what? Subtraction, minus minus, this get cancelled. What is the remaining part? Minus x to the power 6, minus x to the power 6, correct? Now, again further, x to the power minus x to the power 6 divided by x, it is minus x to the power 5, multiply this. So, minus x to the power 5 into x plus 1, it is minus x to the power 6 minus x to the power 5. Again subtraction, this becomes plus, this get cancelled. What is the remainder? Remainder is x to the power 5, right? Carry this division, x to the power 5 divided by x, multiply this two. So, it is x to the power 5 plus x to the power 4, minus, this get cancelled, minus x to the power 4, correct? Again minus x to the power 4 divided by x, minus x cube, multiply this, minus x to the power 4 minus x cube, correct? So, if you carry subtraction, this becomes plus, this get cancelled, x cube divided by x, how much it is? Plus x square, multiply this two, x cube plus x square, again subtraction, minus, this get cancelled, minus x square. Now, minus x square divided by x, minus x. So, minus x square minus x, correct? Minus x into this, minus x square minus x. Do the subtraction. If you subtract this becomes plus, this get cancelled, plus x. X divided by x, plus 1, and 1 into this, again minus. So, what is the remainder? See here, okay, I think this is visible. What is the remainder? minus 1. What is the remainder? Minus 1. Is this correct? So, let us use division formula. For division formula, what is this? This is your dividend. What is this? This is your divisor. What is this? This is your quotient. And what is this? This is your remainder. What is our division formula says? Division formula is what? Dividend is equal to quotient into divisor plus remainder. Is this correct? Okay. So, this is our division formula, correct? What we need to find out? We need to find out, see, what is dividend? Dividend is x to the power 7. So, you can replace x to the power 7. This x to the power 7 you can replace with quotient. What is quotient? Quotient is x to the power 6 minus x to the power 5 plus x to the power 4 minus x cube plus x square minus x plus 1. This is quotient. Quotient into divisor. What is divisor? Divisor is x plus 1 plus minus 1. Is this correct or not? This is quotient into divisor plus remainder. So, what we need to find out? See here, understand this. We need to find out integral of x to the power 7 upon x plus 1 dx is equal to, now what is x to the power 7? X to the power 7 is x to the power 6 minus x to the power 5 plus x to the power 4 minus x cube minus x plus 1 into x plus 1. Yes? Minus 1. This is your x to the power 7 divided by x to the x plus 1 into what? Dx. Right? So, let us split here. So, first integral becomes this into this upon this. This will get cancelled. So, in the first integral you will have x to the power 6 minus x to the power 5 minus x, sorry, I think we have missed x square, okay, plus x square minus x plus 1 into dx minus integral 1 upon x plus 1 dx, correct? So, what is integral of this? X to the power 6, what will be integral? X to the power 7 by 7, x to the power 5, x to the power 6 by 6, x to the power 5 by 5 minus x to the power 4 by 4 plus x cube by 3 minus x square by 2 plus x minus, what is integral of this? It will be log of x plus 1 plus c. This is your answer. So, this is clear and very important. Alright, please remember this example. Definitely there are chances you will get such type of example. What is the concept? Concept is pretty simple, that whenever you will have degree of numerator greater as compared to degree of denominator, go with division formula, use the division formula, and this is how you can find the integral. Okay. So, this part is clear. Alright, note down this. Now next one, hope this examples is clear to you. Next one is also very interesting, important one. So next example is, we need to find integral of e to the power x into sin x into cos x into dx. e to the power 2x is there, e to the power 2x sin x into cos x into dx, correct? Okay. Now see, we have not solved this example previously, but definitely we have solved such type of example, right? This you can solve by u into v. This is your exponential function, this is your trigonometric function. So according to LIATE, what comes first? Trigonometry first comes, then exponential. This becomes your u, this becomes your v, correct? So same approach we are going to use in this case also. See here, let us convert this. See, we know sin 2x. What is sin 2x? It is 2 sin x into cos x, correct or not? So what we will do, see, if there are two terms u into v, right, we can get the integral. So what I am going to do, I am going to divide by 2 and I am going to multiply with 2. So my example becomes 1 by 2 integral e to the power 2x into, what is 2 sin x cos x? It is sin 2x. Now this I can solve. Why? Because it is in the form of u into v. This is exponential function, this is trigonometric function, this becomes my u, this becomes my v, and let us apply u into v. Right, you can pause the video here, solve by yourself, and at the end you can refer the answer. Okay, so this is 1 by 2, let us apply u into v. First function, what is first function? Sin 2x into integral of second, what is integral of second? E to the power 2x, what is integral, or let us write, okay, minus integral derivative of first, okay, into integral of second. Right, solve this. So this is equal to 1 by 2 integral sin 2x into, what is integral of e to the power 2x? E to the power 2x by 2, correct, minus integral of, what is derivative of sin 2x? Yes, tell me, what is derivative of sin 2x? It will be cos 2x into 2 into integral e to the power 2x, it will be e to the power 2x upon 2 into what? Dx. Correct or not? Okay. So these two we can cancel. Right? Okay. So let us multiply with this. So 1 by 2 into 1 by 2, it will be 1 by 4 into, what are this term? E to the power 2x, e to the power 2x into what? Sin 2x, correct? Minus 1 by 2 into this, minus 1 by 2 into integral e to the power 2x into cos 2x into dx. So again you are having u into v form, let us use that. So which function is to be u, which function is to be v? This is exponential, this is trigonometric, again this will be your u, this will be your v. Simple? Okay. So this is 1 by 4 into e to the power 2x into sin 2x minus 1 by 2. Apply u into v now. First function, into integral of second. What is integral of e to the power 2x? E to the power 2x upon 2 minus integral. What is derivative of cos 2x? Minus sin 2x into 2 into integral of e to the power 2x, e to the power 2x upon 2 plus, right? So anything get cancelled? Yes, of course, these two will get cancelled. What you are having? 1 by 4 e to the power 2x into sin 2x. Again multiply with this. So 1 by 2 into 1 by 2 minus 1 by 4 e to the power 2x into cos 2x, right? Minus minus, it will be plus, plus minus, it is minus 1 by 2 integral e to the power 2x into sin 2x dx plus c. Now what is this? What is this? 1 by 2 integral 1 by 2 integral e to the power 2x into sin 2x. It is nothing but what? I. Let us replace this with I. This is your I. So integral becomes 1 by 4 e to the power 2x sin 2x minus 1 by 4 e to the power 2x cos 2x minus 1 by 2 I plus c. You can take to the left hand side and you can further simplify. Correct? Complete this. Right? See, next step will be what? This minus I by 2, it becomes plus here. So I plus I by 2, the rest term as it is. Right? So I plus I by 2, it will be 3I by 2. Okay? Okay. Or what we can do, see this complete term, instead of writing this complete term you can replace with I. Or simply take I here. So it will be 2I, 1 by 4 e to the power 2x sin 2x minus 1 by 4 e to the power 2x cos 2x plus c. Take this 2 to the right hand side. Okay, this also you can solve. So I hope these examples are clear to you. Now for practice I am giving some example. Please note it down and you can try this example. Write down first one. First one, integral log of x square plus 1 dx. Okay, I am going to discuss process also, how to solve. Right? See, we have solved one example, integral log x dx. In the same fashion, solve integral log x square plus 1. Okay, further you consider 1, this is logarithmic, this is algebraic, and proceed. Okay, this is important one, please try it. Second one, integral e to the power 2x into sin 3x dx into sin 3x into dx, right, u into v. Then third, integral cos root x into dx, right. Then fourth and fifth. Fourth one is integral x into cos cube x dx, integral x into cos cube x dx. Okay, and last one, integral x square into tan inverse x dx, right. So all these 5 examples, these are based on what? Integration by parts. Correct? Integration by parts. So even if you do these 5 and whatever examples we have discussed, that is more than enough, right. So let us quickly revise everything. So this is what formula you need to remember. Topic is integration by parts. Integral u into v dx. So first function into integral of second minus integral of derivative of first into integral of second. Now which function is to be considered as u, which function is considered to be v? For that, what you need to remember? You need to remember this rule, LIAT, right? From left hand side, whichever function comes first, that will be your u, and next will be v, correct? Now some important examples from this topic. First we have discussed about cos inverse root x, right? So I have not taken very basic example, cos inverse root x. So for this, what is your substitution? Substitution is root x is equal to t. So we have converted this example into u into v, and then we have proceeded this, okay? Then second, which we have discussed, integral sec cube x. This is also previous year question, please remember this. Important is which function is considered as u, which function is considered as v, correct? Next we have discussed about okay, these formulas are important, okay? I think in the first slide we have discussed this, okay, this formula, okay. I have not taken much examples based on this. In the regular lecture we have discussed this, right? Formula. So derivations are also important, right? In the board exam you will get derivations also, and MCQs are also expected on this, okay. Then simply method of substitution is there, and then u into v, right? Integral log x is important. How to find integral of log x? Then sixth, this is also important example. So what is the concept? Whenever you will get degree of numerator greater as compared to degree of denominator, we are going to use division formula. So here we have carried out the division, and then we have found integral of this, correct? X to the power 7 upon divided by x plus 1. So important, please solve this, okay? See, you simply don't have to watch the video, you can pause the video here, carry out this division, okay? It's not like that I have taken this example, so this is going to come into your exam, okay? Terms might change, so you should be able to carry out this division, that is the part, okay? So this is important one. Then this is also important, this is not directly given as u into v. So we have converted this example into u into v by using multiple angle formula, cos 2x. So instead of that sin 2x, you may get question based on cos 2x, tan 2x. So you have to use this concept there, okay? And these are some practice questions which you need to solve, right? So already see, this type of examples we have already discussed in this lecture only. This is one important. See, there are three variations in this: x into tan inverse x, x square into tan inverse x, x cube into tan inverse x. All three examples are important. Most of the time you will get this type of example. Here we need to use cos 3x formula. You can replace this cos cube x with cos 3x formula and then carry the integration, right? So hope integration by part is clear to you. In the coming lecture we are going to revise integration by partial fraction. That is also one of the important topic, and we will solve some previous year questions. So hope with this integration by parts is clear. We will meet in the next lecture. Thank you everyone.